Hello, today we'll be working on LeetCode 111, minimum depth of binary tree. So the minimum depth is the shortest path from the root node to a leaf node. A leaf node is a node with no children, or in other words, both the left and right are null. So let's start by working through the different types of inputs we could get. Alright, so the root node could be null, and if this is the case, we could just return 0. So the next case would be if we only have one node. So in this case, the root node is also a leaf node because both the left and right are null. So we would return 1 because it takes us one node to reach a leaf node. Our next situation would be if only one child is null. If this is the case, we'd want to traverse down the valid side until we reach a leaf node. So if we'd ever come across one side being null and the other having it, we would just ignore the null side altogether. And then our last situation would be if both children are valid, we have to traverse down both sides and then compare the total amount of nodes in both paths. So that's our thought process for traversing the tree. Now we'll talk about returning the shortest path. So the idea behind this algorithm is that once we hit a leaf node, we'll start building up the totals for the paths. So once we reach a leaf, we'll return 1, and when we return into the previous calls, we'll add 1 to the return value. So if a previous node has 2 valid children, we'll compare and return the smaller of the two. Alright, hopefully all of that's making sense, and I hope that the animations helps to clear everything up on how we're moving through it and how we're returning the values. So let's go ahead and step into the code and show you exactly how we're going to implement this. So the first thing we're going to do is check if the root is null and return 0 if it is. Next, we'll create a function called depth, which takes a node. Our base case is if both the nodes left and right are null, then we'll return 1. Next up, if the left node is valid and the right node is null, we'll traverse the left node and return the result plus 1. This if statement is the opposite, so if the right is valid and the left is null, we'll traverse the right and return the result plus 1. So if we get past those if statements, it means we have 2 valid children, so we'll traverse the left and the right and add 1 to both results. We then return the smaller of the two by putting their results in math.min, and then we call depth and pass the root, and we return that from our function. To get a bit better with making recursive algorithms iterative, let's implement an iterative solution. So same as last time, we'll return 0 if the root is null. We'll create a stack to keep track of our calls and a map called depth to store our visited nodes. We'll loop as long as we have a value in the stack. We'll then pull out the item at the top of the stack by getting the last index with stack.length minus 1. Now we need to traverse the tree, so if the nodes left isn't null and we don't have a reference to the nodes left in depth, then we'll add the node to the stack. The loop will start over and make the left our current node. So if the node's left is null, or we've already captured it, we need to see if we can move into the right. These are the same conditions as the previous statement, but for the node's right. So this else statement is where we capture the values for our path and remove nodes from the stack. So remember our conditions. We have two valid children, 1 valid child, or no valid children. So our first condition is going to be for 2 valid children. We have the nodes right and left in the map. We'll put our current node in the map and assign it the smaller of its children's values plus 1. So these next two conditions are if only one child was valid. The left is valid and depth doesn't have the right node. We'll put our current node in the map and assign it the left's value plus 1. And we do the same for the right child. If the right is valid and depth doesn't have the left, we'll put our current node in the map and assign it the right's value plus 1. Else, both the children are null, so there are no valid children. And we will set the node as the key in depth and give it a depth of 1. So this is our base case in our recursive algorithm. So our checks throughout this algorithm are looking to see if we already have a value for that current node. Okay, so after capturing a node's depth, we can remove it from the stack by popping it off. Lastly, our root node will be the final node added to depths, so we can grab the value of our root node from depths and return it. Alright, I hope you learned something today. If you have any questions, please leave a comment below, and I'll catch you in the next video.